We're standing in front, or I'm standing in front of a pea field that you can see directly in behind me. The ground we're standing on is a little damp, it's a little moist, we're picking up a little bit of mud, and that may be a little bit apropos for what we're about to discuss, because the study that you see in the background is looking at root rot diseases in field pea. Field peas, pulses in general, and in Western Canada, Canada is the leader in pulse production. Specifically in Saskatchewan, we lead the pack. And pulses have become a mainstay within our crop production. With our success, though, has brought some problems. And in particular, one of them is diseases. Anytime you get some sizable acreages of any crop being produced, diseases happen to follow along. And for a lot of years we were relatively okay. For something like peas, sclerotinia was the one that we may watch out for. In recent years, particularly those years that were wet up until about 2016, we saw a dramatic increase in root rot incidences in field peas. In specific, Aphanomyces is the one that we are most concerned with. Generally, and where they're the most devastating is early in the season at the seedling stage of development, and the plants will yellow off and literally die. Seedling is the most susceptible time for development of it. Happens under cooler, wetter type of conditions. As the season progresses, we can still have root diseases occur at any point in time. But obviously, when you get to the stage where we're in at this, or where you can see the peas right now, we are starting to pod, or they're podding out. And we're actually got some pods that have got seed development starting into it. If diseases were to occur at this point in time, the impact on yield is certainly not the extent as what we would have had at the seedling disease. Aphanomyces is one of those pathogens that once it's in the ground, it's a soil-borne type of disease, and it's long-living. So right now, with the severe areas of the province of the Northwest that were the mainstay of pea production at one time, guys in that area, producers in that area, have a hard time producing peas, period, because of the disease incidence can be that bad. Here on the research station in Outlook, pulses were our mainstay in our crop rotation systems. So filler blocks, areas that were not in research at one time, we would incorporate field peas. We went away from that about 5 or 6 years ago, and we've now used soybeans as our pulse in rotation. Again, for the simple fact that we could not, our peas were not sustainable for us. We had poor production, and often we were plowing them down. So this site is, we are looking at Aphanomyces root diseases. The first thing we did to establish this trial, and I should say this trial is being conducted both with colleagues Jessica Pratchler at Melfort, and Jessica Weber is the lead on this, and Jessica is at the Scott Research Station with WARC, the Western Applied Research Corporation. This is the third site. All 3 sites had a soil test at the beginning of the year, and all were confirmed with Aphanomyces. So we know it's present in the soil. Now, as you can see in the background, seedling disease was not an issue for us. But our conditions in 2019, up until the beginning of July and into July, we had a full season with no precipitation whatsoever. The only moisture up until July that this field got was our irrigation, and our irrigation was enough to get the crop up and running, but it wasn't saturated. We don't saturate our conditions. I was trying to hold this field at about 80% field capacity in terms of moisture. And we did not see a large manifestation of root diseases into the plot. So we do know it's here, we do know it's present, but the conditions, as I say, have not been such that they've manifested themselves up until recently. So between the last snowfall event we had until a week or two ago in July, the beginning of July, then the rain started hitting. And I'd say within about a 2-week period, we've had better than 3 inches of rain now. There was a period where we got a sudden downpour. The crop did go yellow, the feet were wet, the roots were saturated, the crop yellowed off. A little bit of drier conditions, they they did increase. We have gone in recently, a few days ago, we went in and we did root evaluations of our disease. It is present. We do have root diseases. But I suspect, again, just looking at the crop, that our yield losses will be minimal. The objective of the overall trial was to see if we can look at a combination of input products that will not be able to beat off or prevent Aphanomyces root rots from starting, but will the combination of these products allow us to develop a healthier root system that might mitigate the total amount of root rot that we see developing and minimize our yield losses associated with root rot should it occur. And this follows some research that has been done here in the province by both the Northern Applied Research Foundation at Melfort and Western Applied Research Corporation at Scott, where they looked at basically a base level of production with field peas. And by base, what I'm saying is they seeded it at the appropriate plant population, they inoculated it, they applied 20 pounds of P2O5, and they had a Roundup burn off ahead of time, or a glyphosate burn off ahead of time. That was their base. Some of the results are showing when they start layering different inputs on top of it. So they adjust the fertilizer content over and above 20 pounds of P2O5, make it a little bit richer in terms of nitrogen, potassium, or sulfur and phosphorus. Maybe, you know, they saw less of an impact. Can we adjust it with seed treatments? Are they beneficial? None of these, in and of these self, none of these type of treatments really can prevent some serious losses, but a combination might. So that's what we're looking at within this trial. We started off with a base level of input products where, exactly as I indicated earlier, we looked at a Roundup or a glyphosate burn-off. We applied a recommended rate of granular inoculant. We applied 20 pounds of P2O5 with the seed, and that was it. Over and above that, then, what we've looked at is we took the glyphosate, and as a pre-seed burn-off, we also applied Treflan. The reason there is some evidence in the research that certain herbicides can have an effect on the motility of the pathogen itself, its ability to spread. So we applied Treflan. Our next step was to look at, we bounced the phosphorus fertilizer rate. So we've moved over and above that 20. In fact, we've added some potassium and we've added some sulfur into the mix. So we've gone up to a greater fertility level. We've also looked at seed treatments. You know, so all of these things are additive in nature. We keep adding these inputs. The last one we've looked at is foliar applications of micronutrients to see if that can benefit. Bottom line is, it's too early to see. We do have some variation within these plots. As I say, we did not have the incidence of root rot that we would really see substantial yield losses with. But that's the nature of research. That's what we replicate over time and over years, and hopefully with oversights. So, bottom line is, we're not seeing a lot of response within these trials yet, visually. But again, the combine could be the telling feature here. Once we come in onto these plots and actually take our seed yield, maybe that's where we will see these impacts. So come on back in the wintertime and we'll give you an update onto the results.